KVL and AC circuits. Kirchhoff's voltage law states that the sum of all voltages or potential differences in an electric circuit is equal to zero. As can be seen in this circuit, we have our source voltage, we have two resistors, and we have a lamp. We use Kirchhoff's voltage law, we add up the sum of all the voltages around the loop, and we get that E minus 6 minus 4 plus 2 is equal to 0. We solve this and we find that E is equal to 8 volts. AC circuits. Compared to DC circuits, which electricity flows in one direction, AC circuits, the electricity switches directions, hence why it is called alternating current. KVL in AC. KVL can still be used in AC circuits as long as you only add rectangular forms together. As can be seen in this circuit, we have 3 source voltages and then we have one load. To find the voltage of the load, we do the sum of all the voltages around the loop. So we find that load is equal to E1 plus E2 plus E3. We change the polar forms into rectangular forms as we can only add rectangular forms together. So we add the X components, we add the Y components, and we get that load is equal to 15 plus 9.89 plus 9.6441 plus all the Y components added with J. We change this back to polar form and we get 36.8 volts with an angle of minus 20.5 degrees. Now, as can be seen in this circuit, it is the exact same, only we have switched the polarity of E2. Now, when E2 is reversed, we can either write it as negative 12 volts, 35 degrees, or 12 volts with an angle of 215 degrees. So, we do the sum of all the voltages around the loop. We find that the load is equal to E1 plus E2 plus E3. Now we have all the polar forms, we change them into rectangular forms, as we can only add rectangular forms together. We add the X components, we add the Y components, and we get this, we add it, and then we convert it back to polar form, and we get 30.4 volts with an angle of minus 60.93 degrees. Thank you.